Hey everyone, Chris from Automation here, and today I'm going to explain how Loxone heating control should work in a smart home. Welcome to the channel if you're new here. At Automation, we create smart solutions to automate people's daily lives. A few examples of this range from caravan monitoring, brewery automation, and of course smart homes and offices. So today we're going to talk about using Loxone for heating control. This is only a small area of what's possible in terms of automation using Loxone. We use Loxone across all industries for industrial, commercial and custom applications, but where Loxone goes that little bit further is in domestic properties for home automation. If you'd like to learn more about Loxone in general, I'll put a link to their website in the description below. And if you'd like to learn more about how we use Loxone for things like smart lighting, smart security, or would like a tour of a real smart home, we have made some other more in-depth videos covering these areas. Again, you can find the links to these videos in the description below, or they will appear at the cards at the end of this video. The Loxone hardware. So what Loxone hardware will you need for your heating system? This is very dependent on what type of system you're having installed or you already have. And if you have renewable energy sources like solar or air source, ground source heat pumps, perhaps MVHR, this is also going to require some additional hardware to communicate possibly to these devices. So the first bit of hardware that you'll need in any Loxone project is of course the Loxone mini server. And this one that I got here is the wired version, but there's also the wireless mini server Go if you're perhaps retrofitting. So the next piece of hardware you're certainly going to need for heating control are going to be relays. And these are going to be used for controlling valves, pumps, and perhaps triggering boilers and other sources of energy. If you're using the wired mini server, there's already relays built into this. Or if you need additional relays, there's such a thing as a relay extension. But if you're putting Loxone in retrospectively, then you'll need the wireless relays called the Nano IO. Next, you'll need valve actuators, and these will be going on every radiator or on every manifold loop for the underfloor heating. Next, the touch switch, and this is going to have multiple functions, not only for heating, but in terms of heating, this has our temperature sensor built in. Window contacts, what happens with the window contacts is if the heating is on and a window is opened, we can actually set the system to switch off the heating in that particular room to not heat if the window's open. And then finally, motion sensors, which are going to be used to automatically extend heating schedules if you're in a room longer than you scheduled for. So now I'm going to go through some of the key features Loxone can offer in terms of heating, and a lot of this also applies to cooling as well. Zoned heating schedules. So the first thing to talk about is zoned heating schedules. And when I say zoned, what I basically mean is per room. So let's think of this as individual room heating schedules. And what this does, it allows you to have multiple scheduled entries for each day, tailored around how you and your family use that room throughout the day. This is the same as a normal heating programmer, but with Loxone it allows you to control it on a room by room basis, saving energy and not heating the rooms that are rarely used. So for example, the guest bedroom. The guest bedroom that very rarely gets used can have a schedule where it is off for the majority of the time, except maybe in the morning when it comes on for an hour to dry out some possible humidity. You can also have heating schedules associated with your home's operating mode. So for example, one of the operating modes could be away mode, and this is enabled automatically if you've been away from your home for more than 24 hours. And what will happen is your home will automatically disable and switch off all your heating and hot water schedules when it detects no one has been home for 24 hours. Of course, there's no point heating your home when no one's in it. So there's no need to worry about adjusting your heating system prior to going on holiday or perhaps visiting family for the weekend. Automatic schedule extensions. So these room heating schedules can also be automatically extended or switched off based on your presence within that room. So for example, let's take the living room and the evening heating schedule. And let's say that usually your heating schedule finishes at 10 p.m, but you're staying up later watching a film, but you still want the room to be at a comfortable 20 degrees. And because we're using presence sensors or motion sensors, this will detect someone is still in the room and will then automatically extend the schedule for as long as they're in that room for. So it makes complete sense to utilize the presence or motion sensors to automatically do this, rather than having to manually make these adjustments from within the app. And in a similar way, this automatic heating extension will also automatically stop if there is no presence or motion detected for a certain period of time. Usually we'd set this to around 5 or 10 minutes. You can also manually stop these automatic heating extensions by double tapping or triple tapping the touch switches when leaving the room, or setting the house into night mode when you go to bed. Motorised radiator and manifold valves. Rather than valve actuators that are either opened or closed, the Loxone actuators adjust incrementally and proportional to the amount of heat required in that room, and this modulates the flow of heat into that room. This enables the temperature in the room to be kept constant without temperature fluctuations, which increases the comfort in the room and reduces energy consumption. Using motorised valves will allow the rooms to start heating prior to the start of the schedule, so the room is at the correct temperature at the start of that schedule. So for example, you set the morning heating schedule to start at 6 a.m. That means that the room will have started heating up before 6 a.m, possibly around 5:30, and this will make sure that it reaches the set temperature at the correct time. And no longer will you have to worry about going around manually adjusting old thermostatic radiator valves. System learning. Every zonal room in your home using Loxone for climate control is continually learning and adjusting based off the heating curve data of that room or zone. And the heating curve is basically a graphical representation comparing temperature fluctuations across time. And for Loxone to be able to continually reach set room temperatures at the start of schedules throughout different seasons, and as the temperature outside changes, it uses this data to learn and adjust itself. So a very simplified example of this would be if the temperature is set to 20 degrees C and the schedule is due to start at 6 a.m, for the room to achieve this temperature by this time, it may well have to switch on at 5:30. And this is based on the data that it's been accumulating over the last few days. If the outside temperature then suddenly drops and the next day the room doesn't reach temperature until, let's say, 6:05, Loxone will learn that it needs to switch on earlier, or that it needs to open the radiator valves more to allow more heat to flow so it's at temperature again at 6 a.m. the following day. Even better though, Loxone have a weather service which forecasts your local weather for the next few days. And this gives the system a heads up as to what to expect over the next few days, and therefore will be able to proactively adjust itself rather than be reactive. And if you're ever interested in accessing this heating curve data, this is all available from within the app. Heat boosts. So if you ever wanted to boost the heating, this can be done via the app using configurable time switches. And this can be done on a room by room basis, or perhaps you want to heat boost the whole ground floor at the same time. Another option for individual room heat boosts can be that the switch on top of the radiator valve can also be configured to do this. This same boost function also applies to the hot water. And a good example for when I use this is when I'm on my way back from a mountain bike ride and want hot water for a shower when I get home. I can simply open the app, navigate to the whole house tab, and switch the 30-minute hot water boost on. Operating modes. In the app, you're able to create heating schedules based on the operating mode your home is in. and you're also able to create those operating modes. So for example, the operating mode away, which is brought on automatically after not being home for 24 hours, this sets all the schedules in every room to be off until the house is taken out of the operating mode away. And then an example of creating an operating mode could be creating the mode Christmas, then creating a heating schedule based on being home for 2 weeks over the Christmas period, and then linking the two and switching the operating mode on. And this is just one example. Another one might be perhaps having guest mode, and this might be brought on when you have guests staying over the weekend. So the advantages of being able to do this is, rather than having to faff about adjusting your normal heating schedule back and forward like you would using a normal heating programmer, with Loxone you can create a heating schedule for specific rooms based on events like being home over the Christmas period or having friends to stay over the weekend. And once you set up these operating modes and schedules, it's as simple as switching it on in the app or switching it off. Blind assist. So if you have motorized blinds in your Loxone smart home, the system can be set up to lift the blinds when the sun aligns with those windows. And this way the sun can be used to passively heat that room, helping out the heating system. And then as the sun moves around the house, the blinds are able to react accordingly, lowering and lifting as needed. And this can also be used the opposite way, where the blinds come down if the room gets too hot. In the summer, for example, the blinds can be lowered to try and prevent solar gain entering the room, assisting in passively cooling that room. And this is all something that just works in the background without you having to think about it. The system is designed in a way that it knows where your windows are positioned, it knows where the sun is throughout the day, and it knows if the room temperature is too hot or cold, so you can calculate what blinds need to be adjusted and by how much on a room-to-room basis. Door and window shut off. Having window and door contacts installed doesn't just enhance your security system, they also provide a means of automatically switching off the heating in the associated room if the window or door has been left open for several minutes. So I'm sure you can imagine there's no point heating a room if the windows or doors are left open, and trying to keep on top of the kids leaving them open is no small task. But there is an exception to this. In the event of the outside temperature being higher than that of the room, the heating system will remain on and use the outside temperature in assisting to heat the room. Start threshold. The heating start threshold is a setting which basically decides how economical you want your heating system to be. So let me explain. The start threshold decides when the heating source, a boiler or air source heat pump in most cases, switches on based on how much heat the rooms in your home are calling for. So for example, if you wanted to be very economical, the start threshold setting would be set quite high, so the boiler or air source heat pump only fires up when lots of the rooms are calling for heat at the same time. The downside of this would be if you only wanted to heat a single room a small amount, your heating source wouldn't fire up until some other rooms needed heating too. If you're not overly bothered about having an economical heating system and preferred having rooms constantly at a comfortable temperature, this threshold would be set much lower and would fire your heating source instantly whenever a single room slightly dropped in temperature. The only problem with this though is it can degrade the life of your boiler or air source heat pump through switching it on and off too regularly. What I do though, and recommend to our customers, is finding that middle ground where your heating source isn't overfiring, reacting to every little temperature fluctuation, but firing enough to stay comfortable. Emergency shutoff. So in the event of an emergency like a fire or a gas leak or even a water leak, we can configure your system to completely shut off the boiler, disabling it from any further operation until it's safe to do so, preventing further potential damage. And if you wanted to be extra safe, we'd also configure an automatic shut-off of the main gas or water pipe into your home. So valve standstill. Like the majority of things in a Loxone smart home, this is another little something that just works in the background without you having to think or worry about it, and it can be a real faff saver. So let me explain what this is, and some of you may have already experienced this before. But when your heating system hasn't run through the warmer summer months, and then comes the winter when the cold comes back and you need the heating system back on, and what you can sometimes find is where the radiator valves or underfloor heating manifold valves haven't moved for such a long time, they end up seizing up. But because you have Loxone looking out for your home, this simply doesn't happen. If the system realises the valve actuators haven't operated in 14 days, it will then tell them to do a full movement all the way open and all the way closed, preventing the chances of the valve ever seizing. Temperature settings. There are several things to be aware of from a user's perspective within the Loxone app when it comes to heating and cooling temperatures. Firstly, comfort temperature. This is simply the temperature the room will maintain when the schedule is active, or in other words, when the schedule is green or in use. As you can see here, it's set to 20 degrees C. Below that is tolerance. This is a plus or minus temperature the room is permitted to deviate before reacting by enabling the heating or cooling. So in this example, it's set to 1.5 degrees, which means if the room suddenly dropped due to an external factor out of the control of Loxone, like an extreme sudden cold spell or a draft was let in from another room in the house, once the temperature dropped down to 18.5 degrees, that's 1.5 degrees less than 20, Loxone would automatically trigger the room to start heating up. And this is exactly the same if you had an AC or ventilation system for the cooling. If the temperature rapidly increased due to the sun, the cooling would then come into play. And the higher this threshold is, the more economical your system will be. Next is the not in use section. As you can see, this is where the lower limit and the higher limit temperatures can be set when the room schedule is not active. Or in other words, when the schedule is grey or not in use. As you can see in this room, the lower limit is set to 2 degrees, which means when the schedule is not in use or not active, the system will automatically prevent the temperature dropping below this lower limit of 18 degrees. These limits are relative to the comfort temperature above, so you won't need to adjust them whenever you adjust your in-use comfort temperature. And again, the same principle applies for the upper limit if we were using ventilation or air conditioning for cooling. The system will automatically prevent the temperature exceeding this upper limit of 23 degrees. And it's worth pointing out that there's a bit of a debate around which method is better for energy saving when a room is not in use. One side of the debate is in line with what I've just described, believing it's more efficient to not allow the room temperature to drop too low. And the other side of the debate believes it's more efficient to completely switch everything off, then blast it all at once when it's needed. Both methods are possible options when using Loxone. The final section is the off section, which includes frost protection and overheat protection. When the heating or cooling system is off, like when we're on holiday or away for the weekend, the system is never truly off, as it will always be monitoring the temperatures in the room. So for example, with frost protection, if the temperature drops down to 10 degrees, the heating system will automatically kick in, preventing the possibility of pipes freezing over when you're away. And it's the same thing for cooling and overheat protection. If the temperature in the room exceeds 35 degrees, the cooling will automatically kick in to bring the temperature back down. This can prevent wooden flooring from swelling, artwork from being damaged, and in extreme cases preventing pipework from warping. I know that we've covered a lot today and it seems like a lot to think about, but in reality 95% of the things discussed work in the background without you having to worry about it or make changes to. The Loxone system is also fully capable of managing various types of heating or cooling sources at the same time and intelligently deciding which sources to use when. Renewable energy sources like solar, air source heat pumps, ground source heat pumps, and devices like battery storage and car chargers can all be managed by Loxone. And if you're looking to achieve passive house standards, Loxone can help achieve this too. Anyway, that's it for now. Many thanks for watching, and don't forget to like the video if you learned something and subscribe to the channel for more videos in the future. And if you're looking to use Loxone for your home automation system, please don't hesitate to get in contact. See you on the next video.